Hi, this is Tim. Welcome to the Math League YouTube channel. Today we're going to be looking at problem number 7 from target round 12115. Now this is the middle school test that was given out in January and February of 2021. Let's take a look at what the problem says. It says that x plus y over x plus x plus y over y is always greater than or equal to some number for all positive real numbers x and y. In other words, it doesn't matter what you plug in for x and y, it's always going to be at least as big as c. So you can see that plugging in different values of x and y is going to give you some range of possibilities for that sum of the two fractions. And no matter what possibilities you get for the sum, it's always going to have to be at least c. So what that tells us is that if we find the minimum value of the lowest possible value that x plus y over x plus x plus y over y could be, then that's going to be the c that we're looking for, right? That's going to be the number that we're always at least as big as, no matter what x and y are. So what we need to do is minimize the value of x plus y over x plus x plus y over y. Now, I can split out these fractions, right? X over x is 1, and then I've got a y over x. And then x over y I've got, and I also have a y over y, which is 1. And again, I want to minimize that. Well, the ones, you're stuck with them, right? You can't make the ones bigger or smaller. So the only thing you can change in terms of minimizing is the y over x plus x over y. Right, so what we want to do is minimize the fraction y over x plus the fraction x over y. If we can minimize that, get that as small as possible, then the line above is also as small as possible. And that tells us the smallest thing we can ever get for the sum of the two fractions. And again, once we found the smallest that can be, we set that equal to c, and it turns out that no matter what we choose for x and y, this equation is going to hold, or this inequality is going to hold that we have at the top of the screen. All right, so what we need to do is minimize this sum of two fractions. Well, notice that those fractions are reciprocals of each other. So what we really want to do, we can just replace it with call y over x q and call x over y the reciprocal of q, right? So we want to minimize q plus 1 over q. Now, you can start by plugging in some numbers here and see what happens, right? If q is 5, I've got 5 and a fifth. If q is 4, I've got 4 and a fourth. Well, it seems like the lower we go, the better off we're doing, right? Keep in mind, of course, that q does have to be a positive number because x and y are both positive, which means that their quotient is positive also. So, q is 3, I've got 3 and a third. If q is 2, I've got 2 and a half. If q is 1, I've got 1 and 1 over 1, which is 2. So as I continue down towards 1, we see that we can get as low as 2 for a sum of a number and its reciprocal. Can we get any lower than 2? So if we put q equal to 1, then q plus 1 over q is going to be 1 plus 1, which is 2. Can we do any better than 2? Now, the solution that was given out with this test involves the AMGM inequality, which, of course, if you understand that and it makes sense, great, go ahead and use it, right? Well, I want to show you a different way to do that in case you're interested in seeing how it's done potentially without the AMGM inequality. So, again, we were able to get this as low as 2. The question is, can we get it any lower than 2? So what we want to do now is ask ourselves, okay, if q equals 1, we got a nice value of 2 for this minimum. What happens if we move a little bit higher or lower than 1? So what I'm going to do is I'm going to take this 1 plus 1 over 1 equals 2. Wonderful. Question is, can we do any better by adding a small number to it? All right, 1 plus a plus 1 over 1 plus a. What can we find out about that? Can we make that thing less than 2? That's our real question. All right, let's try it out. First off, let's go ahead and multiply both sides of this inequality by 1 plus a. We are assuming here that a is greater than -1, all right, because we don't want to be multiplying by a negative number. But saying that a is greater than -1, I mean, basically you're saying that I'm not going to drop my reciprocal below 0. All right, so as long as a is greater than -1, we're going to be able to multiply both sides by 1 plus a. And let's see what we get. 1 plus 2a plus a squared. That's what we get when we multiply this piece by 1 plus a. And then I'm going to add a 1 to it, right? That's what happens when we multiply that by 1 plus a. And can that be less than 2 plus 2a? That's what we get when we multiply the right-hand side by a 1 plus a. All right, let's move some things around here. And we see that we have 2a on both sides that we can just subtract. Then I have a squared plus 2 is less than 2. Can I get a squared plus 2 to be less than 2? Well, subtract 2 from both sides. Can I get a squared to be less than 0? And of course, the answer is no. I can't get a squared to be less than 0. Which means that if I can't get a squared to be less than 0, I can't get this to happen, which means I can't get this to happen, and I can't get this to happen. In other words, adding an a onto the 1 in the numerator and the denominator will not allow us to get anything that's less than 2. So the best we can do is a 2 for the sum of a number and its reciprocal. So if that is going to be a 2, that means the minimum here is going to be a 2. And if this part is 2, then the minimum of the overall thing is 4. All right, so in other words, no matter what x and y are, the smallest I can ever get, x plus y over x plus x plus y over y, is equal to 4. Okay, so this thing is always going to be greater than or equal to 4. It's also always going to be greater than or equal to 3. It's going to be greater than or equal to -1,000,000. But we want the highest thing that it's always greater than or equal to. And that's going to be the minimum value of this sum of fractions. And so that tells us that the greatest possible value of c is 4. And that's how it's done. Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.